For this example, we have that the amount of CO2 in the atmosphere in parts per million has been increasing as a result of fossil fuel usage. Or I'll say that I do know that for some people this is a bit of a controversial example, but it is the one we're working on, so bear with me here. In 1960, the concentration was 317 parts per million, and the average global temperature was 57.04 degrees Fahrenheit. Meanwhile, in 2009, the concentration and temperature increased to 385 and 57.99 respectively. Use the data points 317, 57.04, and 385, 57.99 to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million, rounding m to 3 decimal places and b to 1 decimal place as needed. So here we have the 2 points given and we need to find a slope. We're finding a slope always comes down to m equals rise over run, where here rise is measured in temperature, 57.99 minus 57.04 degrees Fahrenheit, over run, which would be 385 parts per million minus 317 parts per million. So this gives us 0.95 and 68, which is approximately, following the desired rounding scheme, 0.014 degrees Fahrenheit per part per million. Not the cleanest units there, but that's what we're working with. And so if we want to put this into point slope form, where I'm arbitrarily going to pick the first point, you could use the other one if I wanted to, but I'll use the first one here just because, we would have y minus 57.04 is equal to 0.014 times x minus 317. And from here you can multiply in the 0.014, which would give us 0.014x minus 4.438, and then I will add over the value there to isolate and get that y is equal to 0.014x, and if you add the 57.04 to the negative 4.438, you get about 52.6. Following the desired rounding scheme, I'm going to round that to 53, which is to say that we have our function describing the rise in temperature, in terms of parts per million, which might not seem like a whole lot, but according to the Intergovernmental Panel on Climate Change, the IPCC, should have seen that report that came out a little while ago, we may be expecting larger, faster, more drastic, and for that matter, more permanent changes, barring some pretty major adjustments in terms of our fuel usage, but we'll have to see how that goes. In any case, that's what we have for section 2.3. We're going to finish out the week looking in 2.4 at more of these ideas of how we can develop and understand what slope represents.